Good evening, all. Welcome to Construction Philosophy's academic initiative. We have reached the final day of this course. I would welcome Dr. Anil Joseph to take up the session. And there is no introduction required actually as such, because we have listened to him many times. And I would welcome Anil, sir.
Good evening, all. I think today is the last session of this particular forensic civil engineering. In fact, this is just an eye opener. This is not that you have to learn a lot, and the learning begins once you have the knowledge. You have to put it into practice, and that is what engineering is all about: putting your knowledge into practice. Otherwise, it's just a science. So if you have to apply that into the field, know the result and enjoy yourself, how it is going to benefit the community and the economy and the society and your skill set, then you transform yourself as a good engineer. So I have gone through the sessions which was covered by Surya Prakash. He has covered almost all the forensic aspects of structural engineering, covering 40 cases. In fact, a vast number. So Suresh has talked about the rebuilding. Suresh sir has talked about the rebuilding of the textile building project, which was in Kalur. And then again, he talked about the failure of an auditorium. And it was a very depth analysis of what has gone wrong in that particular cases. And Abhilash has briefed you about the problem of water slopes, as well as the retaining structure, including the problems involved in gabion wall. I have talked to you in my first session about the deep basement excavation problems. So today I thought I will just deviate from the collapse and the other aspects, and thought of bringing to you something which is practically needed, that is the distress evaluation of a structure. And once a distress has happened, how to go about solving that. So it's a two case studies which I am going to present here. One is that of an IT building, and the second is that of a hotel building which was settling, how we have rectified that. Then to close up, I thought I will touch upon a controversial topic, which is the hot Palarivattam flyover. We'll talk to you about what is happening in Palarivattam flyover, who most of the people who are in Kerala knows about that. But then our purpose is to understand what is the engineering and what is going wrong in that particular project. So I don't want to get into the political aspects of that. So let me start with the presentation. May take about 1 hour of time, and we will try to do that at the earliest. Okay, so this is what the course jointly organized by Institution of Engineers, Kochi Local Center, and Construction Philosophy magazine, and the comprehensive reporting, and we told about what is forensic structural engineering. Now today we are talking about the cases of evaluation of distress and remedies. So these are very small things, but then small things makes a big differences in the real field of practice. So repair and rehabilitation of structures is necessary when it loses its ability to perform its intended design function. And there are two major aspects which happens. One is the structural failure, and second is the performance failure. And what are the reasons which contribute to these failures? One, externally applied load. Your building might have been designed for some particular aspect, maybe a residential area. Later on, it will be converted into a storage space. So it is a externally applied load which is not taken into consideration. Environmental loads, earthquake, wind, and other thing. Accidents like the case yesterday where the blast was talked about, the blast of a LNG or blast of a blast cases was explained by Surya Prakash yesterday. The accidents do happen. Error in design and detailing, that also adds to a major aspect, because certain times we have a lot of factor of safety. That is why we need to have a proper system of checking or peer review, which has to come into practice, which is not there in our country in general. That is where yesterday Surya Prakash was pointing out the need of having the professional engineers bill in the parliament, and the engineers should be made accountable for the work they are doing. Then is poor construction practices and construction overloads, which I was talking about, and change in utility bar function. So these are the reasons which leads to the need of distresses which is happening in the structures. So structure needs to achieve its required strength so that it can be put into service without compromising its safety and utility. Rehabilitation of a concrete structure becomes necessary to extend its life to ensure durability of the structure. Now, how do we understand that the building is easy to notice collapse of the structure in certain cases, like what was happened in the auditorium, which Suresh was talking about, non-occurring of required strength of structural elements, etc. So these are the reasons which lead into the distress of the structures. And how do we analytically evaluate for the distressing structure? So this is the steps to evaluate and rehabilitate the distress in a building. So first we have to physical inspection of the damaged structure has to be done, presentation and documenting the damage, collection of samples and carrying out tests both in situ and in the lab, studying the documents including the structural aspects, estimation of loads acting on the structure, estimation of environmental effects including soil structure interaction. Then we have to diagnose what is the reason cause, find out what is the root cause, taking preventive steps not to cause further damage, retrospective analysis to get the diagnosis confirmed, assessment of structural adequacy, estimation of future use, remedial measure necessary to strengthen and repair the structure, repair evaluation through testing. Yes, testing has to be done after evaluation. Load test to study the behavior, choice of course of action for the restoration of structure. So these are the step-by-step process when there is a problem which is happening or which is likely to come up in your project. This is the way you have to take the step-by-step process. So there is a flow chart also shown on the other side. Physical inspection, we have to study the material test, study of document, estimation of load acting, estimation of the environmental factors, diagnosis, retrospective analysis. If diagnosis confirmed, estimation of future use, assessment of structural adequacy, load test, and choice of course of action. So that is the different procedures which we adopt in order to find out the systematic approach, and the documentation is a big important step which generally we lack. So that is what very essential, and it is very essential for the government authority also to keep necessary documentation with them, so that in the eventuality something happened to a building, and generally it happens after many years of its construction, there should be some dependable document which they can rely upon in order to make sure that the problem is identified and correction is made. It is more important because the safety of public is in question. So our system has to improve to reach up to that level. So today I am talking about 3 cases which I told. One is the IT building at Kakanad, a hotel building at Kottayam, and a flyover at Cochin. The reward for being a good problem solver is to be heaped with more and more difficult problems to solve. This is by Buckminster Fuller, and it's a very important thing. The reward for being a good problem solver is to be heaped with more and more difficult problems to solve. And again, it becomes a passion in you. Then you jump into the problem to understand what has gone wrong. So a good engineer should have the engineering skill and the curiosity in him to understand what went wrong or how it can be attained and how our knowledge can be put into practice. So here, this case one which I was talking about comprises of a IT building, basement plus ground plus 19 floor building. And ground floor, this is the details, what are the floor heights, which I'm not talking to about. My problem was that here the tube strength value for the 28th day compressive strength for 19 columns in my ground floor and first floor level, I needed M45 grade concrete because this is a huge building. It's with a column spans of 10 meter by 10 meter interval. And since the grade of concrete which was designed for M45 grade, it was not achieving the required strength. Quite a normal problem which many of you generally gets in your day-to-day practice, or somebody who is connected in the site will know that this sort of issues generally do come. So what you do generally for that? So this is the project which is completed and functioning now. So my strengths were going for the 19 column in the range of the cube strength. So how we take the cube strength? So we take cube during the concreting and we worked out the 3-day strength, 7-day strength and 28-day strength. Certain times we skip 3-day strength and go for 7 days and 28 days strength. And if it has to be more than what is required, but here it was not coming. And what we should do for that? So we decided to go for maybe something gone wrong with the cube making, and cube making is also a very important essential thing. Many site engineers who are here make sure that your cement will be best, your sand will be best, metal, everything what is used including the water, everything is the best possible, but your mixing procedure is a very important aspect. Again, you might have a very good concrete team who is doing the job perfectly. The man who is taking the cube, if he doesn't know how to take cube properly, we end up with big problem. So that please make sure that it is getting attended to. And one thing which we generally lack is good concrete engineers. We lack good concrete engineers in the industry. We are struggling always with the grade of concrete, starting in the initial phase of the career to get M20 from M15, then M25, M30, and within 1996-97 we started going to M30, M35, then moved to M40. M40 was stuck there for quite a long, and now we moved into 45, 50, 55, 60, and currently in Cochin we are doing a couple of projects which is at M60 grade concrete. Still we are able to achieve up to M80 grade concrete. And whereas if you go abroad, people are using 100 grade concrete, 120 grade concrete. Why? As the compressive strength capacity increases, your size of the column can be reduced, your steel can be reduced, economy can be achieved. So now there is a lot of technology which brings in high strength concrete. That's a totally different topic which I am not going to touch upon today, but I am worried about what is going wrong in our concrete at site. And if something goes wrong, how to manage that. So the following non-destructive tests were conducted to determine the compressive strength of the column. So what we did, we went for rebound hammer test, and to confirm the values we went for core testing. So it was a very critical project. The loads was important, so we didn't wanted to take chances. So this was the non-destructive test which was carried out. Rebound hammer test conducted on RCC column showed that the estimate strength of the concrete in RCC column member after necessary correction is varying in the range of 31 to 44 Newton per mm square. Again, we went for core testing. Core testing is something which, if you are getting it done, be very careful because it is very essential that the core is taken properly. Core test of the concrete was done at the site for various selected strength deficient column, and the core was evaluated based on guidelines given in clause of IS 456, and compressive strength values are found to vary from 30 to 45 Newton per mm square. So means we have a problem there, and how to go about to strengthen the column. So what can be the reason? So a lot of study, there was a lot of arguments how to find out, and I should remind you that the project was executed by one of the biggest contractor in India, and the quality control was done by an internationally acclaimed PMC which was doing that. So again, low quality aggregate for concrete was suspected. Fly ash based cement, the type of cement was changed, again redone, the testing was done. Low quality of workmanship, every point including the point where the loading was happening, it was checked, cross verified. Nominal size of aggregate mismatched with that of mixed design at the type of casting, that also was cross verified. And there we have to come up with a solution. So all these trial and error tests were done. We were trying to get the batching done, and trial cubes were made, but we were not able to come out of the problem. Now, what are the solutions possible? One, demolition of the columns which have not attained the required strength and recast the member wherever possible. But unfortunately, by the time the 28 days strength comes in, your building has gone another 2 floors height or 3 floors height. So there is a problem that by the time when you come to a decision, already the building, there is a loading on top of that. Then you can retrofit using carbon wrapping, or there are n number of systems available, steel bonding, plate bonding, etc., and go for column jacketing. Since here, in many cases, if there is a possibility, especially on big projects, as a structural engineer, I insist on demolishing the column. Because once you get the column demolished, especially if it is a main contractor, he will be careful throughout the remaining part of the projects. If you allow them to do some solutions, then it will be a big problem later on. So I have the experience on very tall buildings where in say 30 floors, 35 floors buildings, where we made sure that the column is dismantled even if there is a considerable degree of damage to honeycombing. We didn't allow, we generally won't allow them to get away with pressure grouting and other aspects or carbon wrapping or other thing. But on the upper floor where it is very late, difficult to get it done, and where the loss of strength is not very critical, certain times we go for retrofitting using carbon wrapping. And then column jacketing. If the size of the column can be increased, we go for column jacketing. So here, what happened for this project, we went for column jacketing because it was on the lower floors where the loads were considerably high, and we thought that it is better to have an increase in size so that it is made sure that it is taken into consideration. And these were the procedure which was adopted for column jacketing. Preparation of existing column surface by cleaning of dust and other exterior material sticking in the column, providing and fixing of shear connectors and stirrups of 8 mm dia inside 12 mm dia holes at 110 mm deep at 500 mm center to center after cleaning the holes to remove the dust particles and fixing the shear connector using lock fix polyester resin anchor grout, supply and application of Nitto Bond EP epoxy bonding agent so that the old and new concrete get bonded with each other, providing shuttering with steel or polished surface, providing RCC M45 using M40 6mm downgraded hard grind aggregate including machine missing, playing, laying, vibrating, applying curing compound and supply and fabricating steel in reinforcement. So these were the different process. The original grade of concrete was M40. How do we solve this problem? Grade of steel Fe500, column size 1000 by 2000, reinforcement provided 5632 mm bars. So checking for reduced concrete tube strength, we found that the only 34 Newton per mm square is there. So what was the actual condition is again re-put into the model, analyze for what will be the behavior, and based on that you increase the size of the column and make sure that your steel is sufficient or steel provided is more than what is required for the particular size, and verify that it is sufficient for this particular size and increase the size of column. So here you can see that we have increased the size of column to 1200 by 2000 and additional reinforcement for column jacketing was made, and mixed design without fly ash was adopted and fresh design message was done. The cement brand was changed. Quality control team experts, we brought in about 3 to 4 concrete experts to work out what is the real problem. Vibration concrete was suspected, curing of the column was suspected, and finally detailed evaluation and study, we found that the M sand which was used was having lesser aggregate and the quality was poor, and that has led to all this sort of problem. So we spend so much of money and energy, so it is very important that the sourcing of the material is very have considerable effect, especially now when we are going to use M sand instead of river sand, and which is a necessity nowadays due to non-availability. Make sure that it is properly being brought in and studied properly to make sure that it is of the required standards. So that is the finally we got it done and the project was completed after the necessary jacketing. So it is better to solve the right problem approximately than to solve the wrong problem exactly. Now this is a hotel building at Kottayam. Again, 2 blocks with an expansion joint in between. It's a G+2 floor building and only 9.45 meter, 32 rooms and 14 car park. The building was constructed, the design, we were the structural designers. So we have designed the building with a piling, and pile to be resting on rock was given in the drawing. And after 2 to 3 years of construction of the structures, cracks were observed in the building. So further investigation was done and it was found that the cracks were due to settlement or mass movement of the soil. Because what happened, this particular property had an empty property, empty plot in the neighboring area. So after here you can see that mass movement of the soil beneath the file foundation was observed as shown below. The settlement of front block was observed to be more than settlement of the back block, which resulted in the generation of the crack. And here we found that the materials were moving from this side to the plot, which was at a lower level, and the topsoil comprises of very soft clay, and it was going to a bit of a laterite strata and then into the rock. So when we evaluated what went wrong, the work was given to the contractor who was quoted the lowest, and it was his first experience as a piling contractor. And the supervisor was also having his first project. So the quality of piling went bad, even though the design everything was perfect and the rock anchoring has not happened. They have just touched the rock layer, or certain times it didn't went up to the rock, and that led to the settlement, and the soil movement which was happening horizontally also aggravated the problem. So here you can see the settlement pattern which was happening. So we found that if it is left as it is going to be a problem. So the existing building was supported with props, and whatever the shovel was demolished. To avoid movement of soil, touch piles, Assyrian poles were provided along the length of the building where movement was expected. So the entire area was supported so that the lateral movement of the soil is controlled. Also, underpinning of two piles in the same side was done. After underpinning, the settlement was found to be within limits and the building was stable. So this was the underpinning. So this building was constructed in 2006. So this underpinning was done in about 2009 period. Underpinning was done to the highlighted piles, and cast iron poles were provided along the length of the building in order to prevent the soil movement. And after 4 to 5 years, they have changed the structural use. They have demolished certain area in the center to have a connection in between. Expansion joints were rebroken and reconstructed for introducing a lift, and suddenly the building started cracking heavily. So here you can see that once that equilibrium was disturbed, the cracks were formed in large degree. It was you can see the extent of the cracks. The cracks were quite large, and it was also, you can see that the entire system has cracked very badly, and we have to come up with a solution. So what happened? This was the expansion area, and this was the other side, and this was the front side. So what we did, we went for underpinning. Underpinning, what happened? So here previously there was an underpinning and the building was stable. So the readings were observed for quite a long period to understand what is happening. And we found that this particular area where the structural change has happened, that is creating the problem. And also there is a slight movement this side. And once we strengthen this area, we were afraid that there might be some movement this side also. So finally, it was after taking a reading for 6 to 8 months, it was decided that we go for underpinning, cutting of this area. We will go do the underpinning in this area to make sure that whatever the disturbance that has happened is stabilized. Also, we will strengthen this side as well as that side, because practically once the building is functional and completed, it is very difficult to do any work in the center. So here you can see the drawings. So these are the existing pile. These were the additional pile provided, and it was connected to the pile cap, interlinked and hooked into this. And here you can see that this goes up to 16 meter and properly embedded into the hard rock, and the reinforcement was provided accordingly to take care of the loading. So solution was proposed considering all the pile caps were at the same level. But after excavating site, it was found that the pile caps were not at the same level. So the design was revised to suit the site condition. So that is where I always point out this concept of having the dynamic, so that you have to, your solution might not be exact in the drawing board at the office. You have to go to the site and modify it accordingly. So the design was revised to suit the site condition. So every problem has in it the seeds of its own solution. If you don't have any problem, you don't get any seeds. So you have to work out and find what is the solution. So total station survey for measuring the current level of settlement was noted. Propping was done. Piling operation, ready-mix concrete of grade M30 was used. Pipe cap construction was done. Self-compacting concrete. So generally when it is difficult when you are doing underneath a foundation, so we go for self-compacting concrete of grade M30 was used. Guilty was used for fixing grouting steel. Column jacketing was done. 3 columns near the expansion joint where excessive cracks were jacketed for strengthening, and where the disconnected area we did with decking sheeting on top of that. So here you can see that the pile cap, this is the newly added pile, the drawings made ready, and these were the settlement reading observation. So it was continuously monitored. So this is the survey. This is the excavation after propping up. This is the cage work which is going on. The within this we made an innovative piling rig in between this area so that it's only less than 3 meter height. After cutting the slab, we brought it inside and we were able to drill and reach up to the rock. And here the concreting which is going on. So after the piling work, the pile chipping work is happening. And here is the excavation for the pile and the pile cap, the steel work getting anchored here. This is the form work being done, and here it is that concreting using the self-compacting concrete, and where the load of this column has been taken up by this pile cap and now will be bypassed through the new additional pile, and whatever be the settlement will be controlled based on that, and the tie-beams fitting together, and the backfilling is being done. So here you can see the column jacketing happening. So this is the shear connectors which is being provided, and this is the decking sheeting system connecting the removed portion so that it is connected together. So whenever there is a problem, initial investigation should be done to check how critical the damage is. And if you have the solution and the data, don't wait for time to pass, especially when you are playing with the consolidation of the soil or the lateral movement of the soil, because the damages will keep on increasing. Immediate rectification measures need to be taken as required. This is necessary to arrest the deterioration of the structure. Damages in structures should be identified correctly, and the cause of the damages need to be determined. Initial investigation should be done to check how critical the damage is. Immediate rectification measures need to be taken as required. So tests are conducted depending on the observed failure. So it's very important to continuously monitor as well as continuously do testing to make sure that things are in place. From the test results, a decision has to be made whether to demolish or to adopt any strengthening methods to resolve the issue. Accordingly, the structure may be redesigned considering the loads expected. So the building is completed in 2016. The readings are made till last 2 months itself, and everything is stable and it's all functioning. And the last floor is also made operational now after the necessary rectification. So this was one case study where a problem of settlement was corrected, where the building was going down over the years, was observed, monitored, found out, because there has to be practical solution, because certain times it is very difficult to find out how to solve that, because the building is existing. So you have to observe and come up with a remedy so that it will be solved for a long duration of time. So this is the Palavatam flyover, the third case which I would like to discuss today. A controversial topic. So for those who doesn't know about this, let me tell you, Palavatam flyover, there is a flyover constructed in NH bypass in Cochin, and the total length of the flyover is 634 meter at a width of 17 meter. There are total of 19 spans in the flyover with a 35 meter long pre-stressed center girder. The others are cast in situ girders. The Roadside Bridges Development Corporation (RBDCK) and the contractor firm RDS has completed the work of bridge in 2 years and 4 months after the foundation stone was laid in June 2014. The approximate cost of the project was 42 crores. And the problem was that hairline cracks and light potholes developed along the continuity joints observed immediately after 2 months of operation. So that was the problem which was there. So this is the flyover. So it was opened in 2014 and 16, and it was operational till 2018. And after 2018, since the cracks have started coming in, and there is a National Highway Checking Authority called TPF who came in, and they found that the cracks are increasing. So they have asked to do a load test and asked to immediately close the bridge for rectification of what is needed. So this is that the story. Agreement between RBDCK and RDS, who was the contractors, was done on 4th March 2014. On 1st June 14, the foundation stone laying was completed, and here the works which is going on. So that is the extension of the road. Here is the pile cap. Piles were carried out, gone to the rock strata, and here is the pile cap, and the pier is being constructed. And this is the pile cap and pier. So this is the aerial photography where the work is going on. This is the concreting of the deck which is happening. This is the slum cone test and the other tests which were taken during the work. So this is the girders which is being placed. So girders getting erected, piling photographs. So here is the work which is going on. Casting of the retaining wall, the pedestal, so the deck slab, the beams, and 12th October 2016, the flyover was inaugurated. And on 23rd November 2016, hairline cracks and light potholes developed along deck continuity joints, and it was reported to KITCO. Proposal of the structural consultant Manjunath for rectifying the cracks was submitted in January 2017. The methodology was finalized in consultation with Professor Dr. P.K. Aravindan. In 17 February 2018, a 3D FEM analysis was done and detailed report was submitted by Professor Aravindan for repairing the observed cracks. So the findings were that type 4 bearings and pedestal P18 and type 2 bearing and pedestal A2 are damaged due to excessive movements and cracking. So pedestal used was not good enough to take care of the movement. Bearings are not placed as per drawing and repair scheme suggested. So this was the repair scheme suggested. Remove deck continuity and nearby bearing cord. Provide 25 mm wide expansion joint at P18. Remove the damaged pedestal and reconstruct. Replace the bearings. Propose to remove deck continuity at specified location. Pressure grout to rectify the cracks and carbon fiber wrapping. So this was what was suggested by Professor P.K. Aravindan way back in 17 February 2018. But what happened, since the traffic was going on and the vehicles were plying, nobody tried to make the rectification. And that is where I told, whenever there is a problem, you have to act immediately, especially when the structure can deteriorate on further loading. And on 16th March 2018, Regional Officer, Ministry of Road Transports and Highway Directed TPF Engineering Private Limited, and they come and inspected and submitted a report on Palladio flyover, and they found that distress noted at some location, and they have suggested to do NDT test to be done on flyover to assess the condition of flyover and load test to be done if required. On 30th July 2018, and meeting between RBDS and RBDCK, even though there was a suggestion given by Professor P.K. Aravindan, RBDCK told that in order to evaluate the detailed design of structure, evaluation of the existing condition, and to suggest suitable remedial measures, it was decided to give the job to IIT Chennai. And RDS agreed to bear all the expenses as per contractual obligation. And IIT conducted tests from July to March 2019. Lot of tests were carried out. And the first report of NDT test, which was non-destructive testing and partially destructive testing, were done. And Professor P. Alagasundara Murthy was in charge, and they have released the test results, which comprises of UPV testing, reboard testing, concrete core testing, and carbonation testing. So here you can see that the testing which is going on. So UPV testing, core samples are being taken. You can see how the horizontally the core, because it was not possible to do the core samples from the top. It was taken from the bottom on a platform which was made. And what was the results or finding from the NDT test results? So here what happened from the rebound test, they have tested at 10,380 points on 13 RC girders, and measured rebound value is greater than 35 Newton per mm square and ranged up to 80 Newton per mm square. So 35 Newton per mm square was the strength for which the reinforced concrete was designed for. And they did UPV test, and they have tested at 5,190 points, and 7% are found to be less than 3 kilonewton per second, and 93% samples were found to be good in the value ranging from 4 to 4.5. And if we do a crack mapping, the 7% are found to be in the area where the cracks are already there. And the core tests were conducted, and core test, like I told you before, you have to be very careful when doing the core test, because proper sampling retrieval is an issue, and then proper covering and curing has to be done, proper testing has to be made, then only the core will represent the site condition. So 79% are found to be satisfying, and lower strength of M22 and higher strength of M51 was noted. And in the carbonation test which was conducted, no damages were detected. So here you can see that the photographs again. And what IIT suggested? IIT suggested to go for retrofitting using carbon fiber wrapping and grouting using low viscous epoxy resin for grouting. And RDS has carried out the rectification works mentioned by IIT Madras, where they did the relaying of the bituminous layer, replacing the bearings was done, replacing the deck continuity joints with strip seal joint. And here you can see that the rectification work is happening. Here the breaking the joints, because I will tell you what exactly was the problem from the engineering concept, which was the theory of going for a deck continuity in order to prevent the expansion, in order to prevent the expansion joints. They have connected the stitch on the top level. So I will explain that with the IS code itself. So this is where the deck continuity was getting removed and restitched together. So here is the maintenance work going on. Here you can see that particular joint being treated, and here you can see that proper expansion gap is again established after breaking the deck continuity. So that was carried out, and on 3rd July 2019, Dr. E. Sridharan sir was called in to study the condition of the flyover, and this was the findings after the study. No strengthening required for the foundation. Pier and pier cap needs to be strengthened with RCC jacketing suitably designed where it was needed. No strengthening of special span, that is the central span, consisting of PSC girders is needed, by the metal bearings has to be replaced with more robust ones. All the 17 RCC spans has to be dismantled and replaced with RCC new PSC girders. So pre-stressed concrete girders has to be provided. Continuity of the deck slab must be ensured over the joints. It was observed that financial implication would be to the tune of 18.7 crores, and it was also recommended that if the cost estimated by IIT Chennai is more than 50% of the replacement cost, the total replacement of RCC girders would be an ideal solution. It was further observed that the advantage of complete replacement of the bridge with PSC girders is that the design service life of 100 years can be expected with normal inspection and maintenance going for a PSC bridge instead of the current RCC decking system which was lying there. So here is the inspection team going on and inspecting that. So this is the Professor Algara Sundaramurthy also there, the team along with the minister inspecting that. And what went wrong? So when it was decided that the building is happening, and as the structural members of the Association of Structural Engineers were also debating and discussing that, the design was done from Bangalore, and we checked up with the agencies, those they are quite known in the country, have designed more than 100 bridges across the country, quite a capable team we was doing on that, and our structural engineers were quite curious about what was going on. So we went in and studied that. So this was the guidelines for design of continuous bridges as per SP 66 2005. Later on, this particular system was removed. The continuous deck system were what they did in order to prevent that expansion gap. They stitched the top portion of the two girders. So this is one girder which is independent. This is the second girder. Only the surface the connection is made to have a tight deck slab. This is the tight deck slab in which the deck slab is hinged over the pier using partially debonded drilling. So this is where the connection was made and how the system was happened. So in order to do that, once they have done that, what happened? The expansion will not be getting arrested at one pier to another pier. So it will start moving. And since the bearing provided, so here you can see that this lap splice tension parts were provided. So this is stitched together. And RDS evaluation of flyover through Bridgecon Infra Consultants was done by analyzing IIT reports. Finding was that minor crack subset are well within the permissible limit of 0.3 mm. The quality of concrete is adequate in the entire structure. Isolated less strength should be interpreted with other tests. All cracks above 0.3 mm should be sealed with epoxy and attempted to grout with low viscosity epoxy grout. And low tests need to be carried out in the span with the lowest strength to eliminate the doubt about any adequacy of design, quality, etc. State government conducted a discussion between IIT Madras and Dr. E. Sridharan, and final decision was taken to demolish the flyover and get it reconstructed through an independent contractor. So this is where we are coming into the picture. So we were, the members of the Association of Structural and Geotechnical Consultants was keeping in touch with what was happening, studying to collect the detail. We went in, conducted detailed evaluation and site visit along with bridge engineers from 2 consultants. Cracks formed are random. Distress cracks are not pressure or shear cracks. We went through the document. More than 3,700 cubes were taken and tested in the presence of KICO engineers and recorded in cube register during the course of construction. All the cube results show strength above 35 Newton per mm square and ranges up to 50 Newton per mm square. Already rectification works worth 2.63 crores completed as per the direction of IIT Chennai team. And we gone through the records, and we have suggested in other cases also. Load test has been adopted in similar situation, especially KSTB tested the Neelimangalam bridge and found to be safe. Basic engineering assessment errors found in report submitted by Dr. Sridharan, where they have told that they have done the pulse velocity test of value of 4 kN per second was interpreted to have only M10 grade strength. There was no test conducted by Professor Dr. Sridharan and team. It was based on the test result conducted by IIT Chennai. Cost of rebuild and associated nuisance to public life has to be considered. Environmental pollution during demolition will create further damages. Loss of carbon footprint and wastage of resources to be taken into account before final decision is made. And we felt that many retrofitting methods such as plate bonding, external post tensioning, carbon fiber wrapping, jacketing, etc. can be adopted for rectification required if any. So the decision of demolition should be the last option and has to be adopted only if safety is at threat. And a load test is essential before taking a decision to demolish the bridge. So as per the meeting, it was decided that the building has to be, the bridge has to be demolished and has to be reconstructed with an independent contractor converting RCTC to PSC. It was decided that it will be done on October 2nd, on October 3rd onwards, the work will begin. And on September 25th, we did a press conference. We told that based on all this study, we don't feel that it is not right to demolish the building without doing a load test. So we approached the High Court, got a stay order for that. And High Court has directed to, before doing anything, already since so much of work has done, the High Court has directed to do a load test. The government went for an appeal against that in the division bench. The division bench carried the matter. We presented all the technical data and we wanted an engineering solution. So engineering solution was more important rather than whatever the other factors are. So we presented the case and we argued that a load test is essential before we take the decision of demolishing, and if it can be rectified at a cost, and as per the final report of IIT, the additional cost will be about 7 crore of rupees only. So including all the additional structuring which was suggested, they told that they will go for jacketing and all the other aspects, even though the initial SP was only 4 crores and already 2.3 crores was done. So even if you do all the job, the cost will be only 7 crores as per the IIT estimate. Why should we demolish a building and demolishing the entire bridge? And again, to reconstruct, we have to spend another 20 crores and another 2 years time for the public, which is not fair enough without doing a load test. So we went that and we got a favorable verdict from the division bench of the High Court. And instead of doing the load test, the government has gone to Supreme Court. And Supreme Court, the case is right now pending. And in fact, we are also arguing on that. And the situation is there, and in which there is a study started that it is beyond repair. Certain engineers point out that it is beyond repair. Certain engineers point out with the technical data that this is within repair and it can be repaired already. So 70% of the repair work is done. Why don't we complete that and operate it to traffic? It's a very controversial topic. I just wanted to share it with this August gathering to understand that engineering, certain times we have to argue like a lawyer and has to come out and make sure that the better engineering prevail. And if something can be rectified, why should we destroy it? That is the entire idea of the Association of Structural and Geotechnical Consultants, backing this in order to make sure that if it is not needed, let us not do that. So every problem has a solution. Sometimes it just takes a long time to find the solution. even if it is right in front of your nose. And with that, I would like to conclude and open it for the interactive section.
Well, thank you so much, sir. Thank you so much for that insightful session. It was a very great session, especially when you narrated the case of Palarivattam Bridge, which was a big controversy, and it was something that we all engineers have to, bear in mind. Our editorial chief, Mr. Gauridasan Nair, is also here. So before we go to the question answer sessions, I would welcome Gauri sir to give a few words.
Yeah. Good evening. I'm extremely sorry that I couldn't be here from the beginning of today's session. Good evening, Anil sir. I don't know who else is there. I'm a latecomer today, so I need to be given the attendance for today. So I'm really happy that this initiative, which has been, piloted by my good friend and younger brother Nebu, leading the construction philosophy team, has been a great success. When we launched this publication, Construction Philosophy, obviously with the blessings of some of the best names in the business, like Sri Sridharan, Sri Anil Sir, and Anita Lucas, and many others, who have been constant writers for us too. We were very particular that this must be a magazine with a difference, where we shall not be looking at profits or bottom line, but rather at quality and a philosophy of construction. And we have tried to do that through thick and thin. We are going through very difficult times, as all of you are, and we have had very terrible times. In fact, keeping people with us, but we have never compromised on the quality of the magazine. And we have tried to look at innovative ideas to be featured in the magazine. And when the huge demolitions happened in Kochi, a person like Shri Anil was with us, Dr. Anil was with us to support us, guide us through the whole process. And we could look at forensic engineering as a very interesting subject for study, which is probably not in the mainstream of engineering studies today. I'm not an engineer, because we thought that these are issues and areas of emergence. And in these emerging areas, our budding engineers or even practitioners need to take a very serious look. Now, one of our other cover stories was by Srimati Anita Lucas, that was on value engineering. And I believe, as we discussed with Nebu over the past 1 week, that is something, construction economics is something that we are trying to look at very seriously, and that's going to be a program during the shutdown on the web. So similarly, we shall be looking at technology, diverse aspects of technology and application technologies, as it applies to your profession, so that once light falls upon all our lives after this period of darkness, I think we shall emerge as a stronger nation and a stronger people and a stronger bunch of professionals in India. And we at Construction Philosophy are grateful to the Institution of Engineers India Local Center, Kochi, with people, very prominent people and eminent people in the profession like Dr. Anil and Anita Lucas and many others, who have been very supportive and who are guiding spirits for us. And Nebu, as ever, is a never say die man. And I'm sure that we shall together use this opportunity to extend the horizons of knowledge, even as we sit in our homes, so that when we hit the ground after the crisis of this pandemic, we shall be capable of taking on a new world with new understanding, new comprehension, new insights, and new technologies. I must thank each one of you, the participants, as also our very eminent lecturers and professors who actually guided through these weeks of very creative engagement. Thank you very much, each one of you, from the side of construction philosophy and also the Institution of Engineers, Kochi Local India, Kochi Local Center, as also our executive editor, Srimati Divya Divakar, and our editorial team, and also from, I think, everybody who wishes to see a very robust engineering profession emerging in India. Thank you very much.
Thank you, Gaurav sir. Thank you for that enlightening words. It. Uh, Let us go for the question answer sessions. Okay, Tibu, go ahead.
I was typing. Good. Thank you, Dr. Anil sir. Wonderful presentation. Enjoyed the case studies, especially the flyover, the controversial things on Palarivattam. I have a few questions. I put in the chat box in the IT building, which you have assessed. The final assessment was. I will go to the first case study, so I can answer on that. The final assessment was regarding the M sand, right? The poor quality of M sand. My question would be, what was there a checking done for 56 days strength? Because the 28 days strength, the tubes are failing. It was not reaching the specified grade. And you have done all sort of investigation on that. Assessment was done for that M sand was failure. But was there a checking done for the 56 days because normally I have done a year, we have also faced the same problem with the concrete tube failure. But we have seen that cementitious replacement like either fly ash or Pozzolana or GGPS, it normally attains strength after 56 or 90 days. It keeps increasing the strength. Not on 28 days, you will not achieve the full specified strength. So that will be a question to debate. Then I'll come to the flyover later on, if you can answer that one. Flyover question I'll ask.
Very good observation and a very important point which you have conveyed, which has to be keep into mind, especially when we are going for PPC cements. The gain of strength in the initial phase will be lower, and it has proven with the records that the strength increases tremendously. Generally, what we do certain times, we take 9 cubes to make sure that 45 days strength is verified. Now, 56 days strength also can be looked into, because the aging of with the aging, the strength gain will be higher. But here the problem was that we didn't have the chance, because we have to go get the building going, because we didn't wanted to wait, because we had a very tight schedule to complete the project, and we have completed it within the scheduled time. So the client was sure that we don't want to take any chances. So we have seen in many cases, like Tibu pointed out, that, so don't worry, even if you are not getting 28 days strength, go for 56 days strength, especially PP, fly ash content and granular based slag cements, you will get the strengths like that. But here the client didn't want to take a chance, but then our values were also quite considerably down, and it was critical column. So if it is not a critical column, generally I advise, wait for some period. If it is not a critical element, we wait and do that, especially for the engineers. That's a very important point, Tibu, you have conveyed.
Yeah, we can do the NDT also later on. So just for academic purpose, we can do the NDT 56 days and
confirm that. But by what happened by the 56th day, we would have been 5 floors up. So that is the problem.
Again, the timing was important. Okay, coming to the flyover, Palarivattam flyover. I know it's a controversial thing, and you have presented your case very nicely on the Geotechnical Association. But I would go with the initial assessment of, I forgot the professor's name, who has done the
Aravind, Professor P.K. Aravindan.
Aravind, doctor. Yeah, okay, Aravindan doctor. Okay, he was asking an assessment regarding the plinth failure. Bearing plinth, the bearing plinth was, it was losing strength. So all this testing which has been done after till the Dr. Idran Sad was there and you were there. So all those analysis, I saw the photos in papers, Times of QH and all. It was a debatable subject at that time. So we were going through all the reports daily basis, because I'm doing the flyover here, 30 kilometer single stretch with segmental bridges. So I'm very interested to see what's happening all around. The problem that I feel, there was no testing done for the tension analysis. It's all the compression analysis done for the compressive strength, right? All the UPB, hot testing, rebound, everything is done for the concrete only. There was no analysis done for the tension part. Concrete analysis, what you will get, okay, it will take care of the compressive strength, the compressive property of the element, concrete, right? But the initial assessment was regarding whether the load was transferred to the bearing, pier cap, pile, all those things. So that has not been taken care. Why we are not having a demolition? Now, I think the debate was regarding whether to demolish the flyover or do jacketing, carbonation, carbon fiber, all those rectification measures, right? This was the point. We were telling to, okay, reinstate the building. But if you see the course of action which happened for the deck failure, pier cap failure, till the pile cap is okay, pier is okay. Deck is getting failed because of the continuity, right? There was no expansion on that. There was a deck continuity was established because of 25-meter span. We were doing bridges is 45-meter span with expansion joint with stitches introduced. I saw the code which I referred. Code doesn't call for a. It's not a male-female double bar security. It should have a sheet there, and it should have introduced a male-female like socketing arrangement where the expansion joints movements have been introduced in the deck slab. I think that was missing in that. The deck slab was missing a male-female arrangement to take care of the movements in the deck. That is first point. Second point, it has to be load testing will be done later only, no, after the rectification only. So are we losing money on that? Because we will do all the rectification and the load test fails, we have to demolish it again, correct or wrong? Because we have not done any rectification till the initial doctors commenced, Dr. Sridharan has come in, we have not done anything, and the flyover was subject to traffic. So all the cracks were developed, and it was developed till the pile cap, I think the pier cap, right? So it should have been demolished and reconstructed. Why we should do all rectification and then do the load testing? If it fails again, all this money is going, right? I just putting my point. I'm not political anything. I'm not debating on the political side, but just putting a technical thing to have the clarification. Sorry.
Thibaut, there was a little bit of disturbance in your this thing, but I understood whatever I understood. I will reply to that. And generally, Professor Dr. Aravindan, a very senior professor from IIT Madras, and who was retired and was practicing in Kochi. And during my younger days, when I have a difference of opinion, especially we used to work, we have worked on many projects together. So whenever there is a difference of opinion, I used to go around the bush before I state that I don't agree with you. So he always used to tell that, Anil, if you are arguing and on a technological point, even you can argue with God. Because unless and until you are clear of your technical knowledge, you are not going to improve further. So he always says, don't hit around the bush, straight away ask, and I will answer what I know. And you tell what you feel. And then over the last, say, 2 years when he was not feeling well, so whenever he had a major project, he used to make sure that I am there in his team. Because that confidence, because if you say yes man to the boss above, so then you always be an yes man, because there is a doubt in the. Now coming to your point, you are absolutely right. The deck continuity system, which was stitched together, the tie deck system was the first time being done in here, and they didn't understood what was needed for that. And especially they went for the wrong bearing parts. So they went for conventional bearing parts, which is used for simply supported deck systems. So they have used that system.
Sorry for that. What is the pod bearing system? Was it a pod bearing used? They used a pod bearing, right?
Pod bearing in one span. Yeah. So and then the positioning was also not right. So this was pointed out by Aravindan sir at that 2017 itself. So he has asked to remove that and replace it. But what happened? The traffic was flying, and then nobody wanted to stop it once happening. And that is where the engineers doesn't have a decision-making capability, because it goes to bureaucracy and it goes to the political party. Yeah. So then it becomes a political party and it becomes a different scale altogether. People, you are exactly right. The stressing was the problem. Now here the component, the movement was not stitched together. What happened? So it started having small sound like that. Then the cracks started forming lightly and it started spreading. Now it has stopped. So what we were suggesting is that already 70% of the rectification is done. So only a minor element which is needed, which requires about 2 months time to get it completed. So the contractor is willing to pay that money. And we have just asked them to conduct a load test. And if the load test is not safe, let us demolish and reconstruct is what we were arguing for. Because again, so like Sridharan sir is a demigod with us. In my house, there is a big photograph with myself and Sridharan sir standing together. And in the year 2005, I was the state president of Engineers Association, and we have honored with him a lifetime achievement award. So and then relation goes from that years. But then as an engineer, like you are pointing out, I was not convinced that whether it should be demolished or not. So that is why it was there. The situation is going on. So let us hope. If it is necessary, if it is a safety requirement, definitely we will demolish it and reconstruct it. But we have to do a load test to make sure that it is okay all around. Because even with this, if you look at the crack, because we have seen it closely, observed it over the period, including Stoke consultant Samuel sir was here. So many bridge experts across the country was here who has stated that, and everybody says that it can be rectified engineering wise. So why should we unnecessarily spend, if we start with 18 crore, you know how the government end up. So this is a public money which is being wasted, and we feel that as engineers, that is why I specifically I had a fall of Arur Church was my topic. But after seeing yesterday's thing, I changed the topic because I thought let us debate certain things. As engineers, we always feel that somebody else will do it. Certain times we have to wake up, like you are pointing out, we have to discuss, argue, and come up with an engineering solution, not the political solution. We will work it out.
No, Doctor, I will add a few more points because Dr.
Yeah,
Ethan sir was telling to demolish it only the deck system, right? Till pile cap was okay, piling is okay, pile cap is okay, pier is okay. Pier cap onwards, pier cap also is was telling okay. Demolish only the deck.
He told we will do jacketing, and he was telling only we remove the deck system and then reconstruct that.
Yeah, so that was okay. But as you said, all the rectification was done and only 2% or 5% is remaining. Then okay, complete it and do the load testing will be a feasible solution than to construct new.
Tibu, my point was that IIT Chennai, the entire team was here for 1 year studying this. They gave up with so much of report. They have done suggestion and 95, say almost 75% of the job is over. So why don't we see? There is always that as a professional, we have to respect each other. Now you are a doctor, I am a doctor. So you have given a solution, and so that can be, when we look at a coin, you see heads and I see tails. So that is the situation. So where we have to come up with a engineering judgment is what we call it.
Okay, let's wait then.
Yeah. Any more? Like yesterday, Surya Prakash was telling that we should have that interaction is what is important. Why we find our time and come to this platform is because we enjoy talking to you people. We learn from interacting with you people. So that is why this platform is there. That interaction is the most important thing. If I come and talk something and leave, I don't enjoy doing that. So we have to debate, we have to discuss, like the point which you told, that 56 days strength, which goes up, which is a very important point for many people to understand, and they shouldn't have to panic based on that.
Very true. And also we have a lot of messages, but I suggest, rather than typing, please come forward and ask.
Yeah, Rinsi Yusuf has pointed out a question. What are the positions where we can go in for a deck continuity system? Yeah, deck continuity system, we can even now, there is a very popular thing, we go for continuous bridge where we don't have expansion gap in between, which is very common, and Professor Aravindan was one of the pioneers in that. So we have here in Cochin itself, there are many bridges which is being made fully continuous bridges where there is no expansion gap. For the bridge spanning up to 1.2 kilometers doesn't have an expansion gap. So you can design the bridge in different systems. So that is called as a continuous bridge where the negative moment will come at the support and it has to be taken into consideration, and the construction has to be made accordingly. So there are many bridges, including the Rajaji bridge, the Salim Raja flyover bridge, the Pachalam bridge. Everything is made as a continuous deck slab system. And there is a lot of economy also if you are going for continuous deck slab system. But the problem is that it has to be casted at site. The benefit is that we can be precasted and erected one by one, and the work can be continued. So that is the two major difference between the continuous bridge and simply supported bridges.
Mr. Faisal Rashid, your turn.
Am I audible?
Yes.
Yeah. First of all, thank you for a very informative session, Anil sir. So my question is, in one of the situation you went for column jacketing. So my curiosity is, how did you ensure the structural integrity of the already existing column and the new section you have created?
Yeah, Faisal, good question.
Yeah.
Generally, what we do is that whenever you have to have a all concrete, no concrete connection has to be made. There will be shear connectors provided between all concrete and no concrete. The surface will be dried in, and there are chemical agents like Nitobond, which is applied, connecting the all concrete to no concrete. So it will be applied, and within this particular period, we will do the micro concreting of the column and increase the size of the column so that the all concrete and no concrete are connected together.
Okay. In one of the slide, I could see one. I think that is a mathematical model, right? You have shown one section, right?
Yeah.
So can we address that? All the means if we are doing that shear connector and all, can we model that in that model also?
Yeah, that is what I wanted to communicate. What we do, when there is a problem at site, we collect the data, put
Yeah.
back into our initial model. Suppose I wanted M40 in my design, so I
Yeah.
am getting only M24. Then we find out what is the inadequacy, and based on that, we will come up with the rectification solution. So that is the procedure. That is what I wanted to communicate today. The procedure system, because even though it's very easy, there is a problem. Structural engineer decides that, but what he does is that he collect the data. He first the cube strength, then like Tibu told, the long-term behavior has to be assessed. Then the conformation, non-destructive testing will be done. Then the core samples will be taken, which is a partial destructive testing. And then we take a decision what is the solution. Certain times our reinforcement or the sections will be adequate without any additional strengthening required. Second is that whenever there is only minor differences, we go for a wrapping system. When there is a lot of, especially compression area required, we go for column jacketing. And if it doesn't work, we have to demolish. So that is also a system which is being applied. Based on the type of the results, we put it back into the model, study that and come up with the solution.
Thank you, sir. Mr. Abhishek Mahapatru.
Yes,
Mr.
sir. Good
Abhishek.
evening.
Yeah. Okay.
Sir, my doubt, till now we have here we have seen many of the case studies. So if there is engineers behind that, means it is already designed and there is some error or anything when it comes. So we have a way that this is balanced by this way. Like today is the case that they have hold up a lift there. So you have got to know that there is already balance and somewhere it is misbalanced due to a new lift is coming up. So you have got to the solution, something retrofitting or demolition, anything. But when it comes to North India, sir, like in Delhi, I have particularly seen, they have just gone up to 4 floors, not many, but up to minimum up to 4 floors in an earthquake zone like that, uh, without any structural much. They have already 2 floors, they go above that, or they anyhow manage to get some columns and beams, they get above that without any proper design. And even streets after streets like that in North India particularly, not engineered structures. If perhaps if someday earthquake will be something like 5 or something like that, they may get some crack or anything. If government thinks on that note that they have some earthquake risk, so what will be the solution then? Retrofitting like something like that will work on that structure which is not even engineered even once. Like Surya Prakash sir that day noticed structures like in huge earthquake in Gujarat. That is already designed structures. Still, they are not designed for earthquakes, so they have got structure in columns. When you come to these structures, even Surya Prakash sir said that in North India, even I have seen that personally. When you come to these structures, they are totally house after house, not engineered once. So, is there any solution to further
Yeah.
retrofitting like that?
Abhishek, very valid question, and that is what something which we say earthquake won't kill people. It is the earthquake doesn't kill the people. It's the engineered, purely engineered structures that are killing the people. So if you take the story, I don't know whether or is the fact which was happened. Surya Prakash might have told this yesterday or not. I don't know. I heard his technical, but I was not able to follow up on the question and answer session. But I will tell you, in Bhuj earthquake happened on January 26, 2001. And after the Bhuj earthquake, most of us were there as structural experts visiting that area, and it was something which was really shocking. We lost about 13,900 odd lives in that. And exactly 2 weeks after that, and if you remember, the intensity of earthquake in Bhuj was 6.3 in the Richter scale. So exactly after 2 weeks after that, there was a earthquake in Seattle in USA of the Richter scale 7.1, and only one person died. And that one person died due to heart attack, because when the building started rocking, he got an attack and he died. Not even one building collapsed. So it is we, the engineering fraternity, who are killing the people. What happened in Gujarat? Due to the people, the builders who wanted to make money. So yesterday Surya Prakash told that 90% of the government buildings stood there. there was no problem, including the Suresh has designed about 150-meter tall tower there in Bhuj, and there was no problem. Suresh, you might have listened to him. So there was no problem for that building. So what happened? All engineered structures stood. All non-engineered structures which you are pointing out collapsed, killing innocent people. So much of money was wasted. So exactly that is happening in Delhi is that there is a study which points out that the 80% of the buildings in Delhi are vulnerable to a earthquake, to a earthquake of a magnitude which is likely to happen in Delhi. 80% of the building won't stand. And now the court has ordered and has made an order asking all the building to be retrofitted, all high-rise building to be retrofitted. Now, what happened? What has happened has happened. Now we have to correct it now. But then let us make sure that the future buildings are created that because end of the day, myself or yourself will be there in those structures at the time of the earthquake. We don't know what is going to happen, or our next generation will be there. So we are creating atom bombs across the country, and there is no checking in our design. We are allowing things to happen, and just for the greed of certain community, we are allowing to make unsafe structures across the country. We have to unite together, make the professional engineers build fast, and make sure that all buildings are engineered properly, so that the whatever be the expected earthquake or cyclone which is likely to happen, the building is capable to withstand that. Take the case of Suresh's project, where that auditorium had fallen without any wind or even an earthquake. So how poor engineering is happening in our locality. So Abhishek, don't worry, it is across the country, it is there. As I and you have to get it corrected. So especially now we are getting old, young people like you have to get it corrected. The people who are sitting in this, who is going to practice this profession, has to make sure that our profession should have the dignity which is needed, and we should take decision. If somebody wants to remove the steel or reduce the size of the column, like you pointed out, construct one more floor, it has to be prevented by law, because the life of people is at stake.
Sir, in one line, my question is, thank you for that. One line, my question is, non-engineered buildings like that, by retrofitting, can they be safe?
Yeah, it can be done safe. Now we have a process where including machinery building. No, so if you might know, there is a big group of schools called Bhavan's Vidya Mandir, which was constructed across, and it was constructed many years back. So maybe 5, 6, 7 years back, they came to us to study all the building and retrofit. So the machinery building also, the old buildings also can be retrofitted to make sure that it will be able to withstand the earthquake. So we can put additional walls, strengthen the walls, including the foundations we have done. And we have done a big exercise to make, maybe 7 years back they came up. They told that young children are studying in our schools. So you do the assessment, you do the study, come up with report, and we will rectify it. So it's a great course they have done. So that sort of education has to happen across the country, where people has to make sure that whatever they are constructing is safe for the forces which is likely to come on that.
Nebu, can I speak?
Yes, yes, Mr. Aditya, go ahead.
Yeah. Good evening, Anil sir. Thanks for your presentation. Regarding your Kochi flyover, because I also worked with the Samuel sir. We have done one test track. And whenever I was in Bangalore, twice or thrice we discussed regarding this project, the flyover issue. And whatever you have suggested, and the professor, Chennai...
Alagasundharamurthy,
Arundam. Yeah, that was the correct, because see, dismantling anything is a last. We can always dismantle and redo. So whenever the retrofitting or any rectification is available, we have to go for that. So in my opinion, also the whatever decision taken by you and team to already 70-80% rectification is done. So let us do first the balance rectification, get his load test, and looking to the overall condition of bridge, and when sir senior experts are already involved. So by experience also you can see and judge that whether it is going to fail or not. So only for justification we can go for a load test and then convince the authority that see after rectification is not failed, so there is no need of demotion.
Yeah, Aditya, thank you. And especially Samuel sir, I should be thankful. He is one who has taken so much of initiative. He's the head of the Stoop Consultants. He was here, I think 5 times he was here in Cochin, just to understand the problem, study the problem and come up with solution. And with so much of load testing data, case studies, rectification he has done, he has presented it to different forums across to make sure that the engineering is not getting killed. And thank you very much. I'm very happy to know that you are associated with Samuel sir. And one more thing, thanks for answering the question which Tejas has put up. Thank you very much, Aditya.
One of the project, he also helped me in one of my test track project. So we were having this sandwich of building and the flyover. Means a test track, the vehicle goes on the gradient and then it has to take turn on the building rooftop and has to come down. There one issue has come that the cracks have been formed in the at the junction. And that time I requested Samuel sir to visit my site because the seniors were asking that this building will be going to fail and this and that. Then I requested Samuel sir, please come at my site and convince the guys, because whatever I have suggested, as per me, there is no need to worry, and only we can rectify it. So, but the other people were not convincing. Then he came to my site along with Sunil Dutt, their other director sitting in Mumbai and Delhi, I think so. And then both the director came, then they had a meeting with my MD and other people, and they convinced. Then nothing to worry, whatever Aditya is saying, it is correct and we can rectify it. Then all the carbon fiber jacketing and other things, we have done it and we rectified.
Thank you. This sort of experience should be shared in the forum like this. That is what the confidence of engineers improve. So that is what I generally feel that we are lacking. We have this exactly, Aditya. Where was the location where you had this?
Where was the location? We had made a test track at Aurangabad for endurance technologies.
Understood. Yeah, thank you. It's a nice information. Next time when we meet Samuel sir, I will convey that point which you have pointed out.
I will send a complete, even I was planning to send all the documents to CP, for other people who can read that, whatever the problem we observed and what was the rectification solution we provided to the client and how we rectified and what is the final result. But for that, the photographs I can't share because it's a test track, and test track, no automotive company normally shares their photographs. So I have to take permission from them first. I was the HOD civil, but I can't share it.
We would certainly welcome it, sir. We would certainly welcome it, even without the photograph.
Yeah, without photograph, I can
definitely.
send photographs.
No, that is one thing which I always support construction philosophy. Yeah, no, that is why always we support construction philosophy, because and this entire concept of CROSS, that is confidential reporting on structural safety. So that is very important. That is what people in UK does. The Institution of Civil Engineers UK is the pioneer in doing this. So we should also start something like this. And construction philosophy has come up with this idea. They came to me immediately after they formed the magazine and told that you should write about your failures. So I told that who told him that I have so many failures is what I was wondering. So this is all, because if you don't have failure, you are not doing enough. So have failure, stretch yourself, learn, try to improve, and keeps on observing. So these are valid points which we, all of us. So tomorrow it might be Rindu Kurian who is going to do it, or Vivek, or so Bobby George. So Bobby George is to ask a question, I think. So definitely we all have to come up. It's all the opportunities which we get and the knowledge which we develop. And the more opportunity you get, the more knowledge more you realize that you don't know many things.
Yes, Anil Joseph sir, I am primarily a journalist. And one thing that I've noticed about in the controversy in connection with our Palarivattam flyover, there's a lot of uninformed writing in the media, completely uninformed writing in the media, where the entire attention was getting focused on other issues. Now, this is an infrastructure we created spending precious money. And a technological choice may have gone wrong or may have gone right. And these things need to be looked at very objectively. So I think when the engineers, as engineers, you learn through your experiences I think it is important for the media also to learn. And our effort at construction philosophy is to become that medium where we shall be teaching our peers, our colleagues in the media and also in the engineering profession about what we can learn from our experience.
Thank you, sir. Thank you.
I agree on that, Gurdas, sir, because I'll just add on some points on that.
Yeah, sure. Yeah.
We saw photographs during this debates happening during the flyover in the media. They took zoom photos in deck slabs getting exposed, the asphalt is going, and the photograph showing reinforcement exposure in the deck. Zoom photos can detect, when you take a photograph in a zoom view, okay, that only will be the rebar is exposed. It can be of n number of causes, not because the structure is failed. Okay, when the asphalt is gone, maybe it's because of wear and tear, because of sudden loading on that area, truck has been moving there, maybe the asphalt was not properly compacted. A number of reasons can be. It cannot be a structural failure. Hype was there, and there was, it was because of political reason. That is why the media was taken in the different, not the technical way. That is one point. Second point is, have we done any global analysis, global modeling on that? That was, I forgot to ask that question to Dr. Anil sir. Have we done any theoretical analysis for that whole subject, other than the core testing, concrete testing? Any theoretical modeling has been done on that structure?
Yeah, definitely. The theoretical model was done. Samal sir was also involved in the modeling, and Bridgecon was also involved. The team from IIT Kharagpur was also involved in their own modeling, and it was all presented and debated in so many forums. But unfortunately, like Tibu pointed out, it has to be discussed by engineers, but it is being discussed by X and Y party. So the solution won't come. So, and the engineers are silent. Like people like us who has this talk won't get the opportunity, and X and Y who is interested in some other story is the one who is talking, and media also goes because of the coverage they get. They go after that.
Right, Bobby George, your turn, Bobby George.
Okay. First of all, thankful to Anukumar sir for the great initiative regarding Palavattum Palam. I have a doubt about the structural condition. I am asking about the Palavattum Palam. As per the structural condition, in the present situation, is it okay for light motor vehicle transportation? Is it okay for light? I think the light motor vehicle transportation is allowed, then almost the 50% of traffic is solved. Is it okay for light motor vehicle transportation?
So, Bobby, your question is very valid. This is what we are sending so much of request across. So, because it is designed for Class AA loading of bridge, IRC Class AA loading has been designed for that, and it was the loading was designed for that, and this loading will be only about less than 10% of the loading, even if you allow the trucks to run on that. So, nothing is going to happen because there for the last 2 years the vehicles were plying on that, and now the base root of the problem was the deck continuity, which was made by deck stitching, which is removed, and expansion gaps has been established. All the bearing parts has been corrected based on the suggestion by Professor Aravindan. All the new bearing parts has been put into place. So almost 9, other than the carbon wrapping and the pressure grouting at the bottom, which is to be done, all the rectification work has been completed. So definitely we can allow the vehicle to run on that. Light vehicle especially, but then political pressure won't allow it to happen. Now let us not debate that. No, I don't want to go one step forward from here. Yeah.
Okay.
Well, Mr. Bhaskar Narmugam, are you there?
It is a basic question. Don't take this mistake, sir. You are told that by checking the column, you are using rebound hammer test. Rebound hammer test gives results very. If it is in a wet area, the value will be lower. In dry area, the value will be higher. It is vary from position to position. How do you accept this value, sir?
So a very important question, because the code itself says that there can be 33% variation. So the variation is quite high, but then that's an indicative test. So already if it's an indicative, because already the concreting is done, casting is done, cube was failed. Now we have to analyze what is happening. So generally the only solution is we do rebound hammer test and the pulse velocity test. And if it is not getting there, we do core sample test. And cores, generally somebody had a question, it's a totally destructive testing or a non-destructive testing. So we generally go for 63 mm dia core, so that it goes in between the bars and we get the data. So it's also not a very reliable thing, but these are taken as crude method to adopt what can be cross-verified, and especially to make sure that make sure to the contractor and the site engineers to be on vigil that the structural consultancy team or the PMC team will be after that, and will be if something goes wrong, you will have to do a dot of rectification form. So that is how we are ensuring that it can be done. Exactly, a very good point conveyed. There can be a lot of uncertainty in the report hammer test. It's a very indicative test. The code itself can stated that there can be 33% variation in the data, but then it's an indicative data. It is something better than nothing. That is what we are looking for. That.
Thank you, sir.
Sir, just I want
Mr.
to share one thing.
Rashid Batra.
Yeah, Aditya.
Hello, sir.
Yeah.
Sir, I was thinking about the differential settlement of the building, and I was thinking, what are the factors that we can see, like to conclude that there is a differential settlement between buildings and all, like factors that we need to consider to conclude the thing.
Rajat Batra, can you come once again? I was not very clear about the question.
Sir, I was asking, the differential settlement between the two buildings are there, and what are the factors that we need to consider to conclude that there is differential settlement between the buildings?
Yeah, it's very easy. What happened is that there will be cracks started forming in the building, and obviously when you walk itself, you can understand that the building is moving on one direction. Especially what we do, we generally pour water. These are crude method. Generally, how we work out is that we pour water and understand what is the level. So if whichever direction the settlement is happening, we know, and we take the levels. The levels properly is measured, monitored over the period of time to understand how the settlement, what is the level variation, differential behavior, and monitor over the time to understand that whether the consolidation is increasing or decreasing. What happened? Consolidation settlement try to converge. So certain times it might keep on increasing. So then you can plan your rectification process, and you have to act immediately, or if there is a time for you to react also, it can be worked out based on readings at periodical intervals. So, and these data will be plotted to understand what exactly is the behavior. It's like a continuous study. So generally when a problem comes, we don't take immediate action unless and until it is very critical. We watch, we observe, we collect data, again we go back to the, after 2 weeks, we again get the data, understand how it is converging or diverging, and with the 2-3 readings, we come to a decision that what has to, whether an immediate action is needed or a long-term action is needed, whether it's a cosmetic treatment only is needed, or whether we have to go for a major surgery.
Yes.
Vishal Philip.
Yeah, hello, sir. First of all, thank you for this wonderful presentation. My question is regarding the underpinning. Like, I have not seen insight or any video regarding the underpinning. So I'm just curious about the construction methodology regarding the underpinning. So my understanding is that there is already existing structure, and like in your case study, we have like made additional piles for the foundation for the existing structure. So my doubt is like regarding the equipment, like, and the effect of the piling on the existing structure. How are they managing all that, like, without affecting the existing structure?
Yeah, Vishal, it's a very important question, because whatever the time, because in theory it is easy to learn, but when we come to practical, it is very difficult. So there, if you have seen my slides, I don't want to bring the slides again now. So what happened is that we had only a limit criteria. So the machine was refabricated in order to make sure that it can be done within that particular height. And again, we do additional pile to make sure that the disturbance is minimum on the existing structure. And in this particular case, since the cracks were so high, I have supported the entire structure independently with additional probes and acro and spans, so that nothing get transferred to the existing building wherever we are doing the piling operation. And after the additional piles were properly seated into the rock, after the curing period, the stitching was done, and the entire column and the pile cap was transferred into the new pile cap. And make sure that during the cantilever action, the load gets transferred into the new building, and the entire things will be supported on jack pressure from the bottom, and once it is released, the load will get transferred to the new pile system. That is the principle of underpinning, and depends upon the case to case and the points where we can do, we vary the system. And even now technologies are there where within the building you can do underpinning, but then it's all complicated thing. And now the concept of micro piling has come up quite a lot for this sort of underpinning jobs.
Okay, yeah, thank you.
Right, Rintu Kurian, your turn, Rintu.
Good afternoon, sir. It was a good, indeed informative session, and your case studies and examples were really good. I have a doubt which is not directly linked to today's session, but it's indirectly linked to the sessions which were held before. We have standard codes for mentioning the earthquake, uh, intensity of earthquake and intensity of wind likely to occur in an area. But do we have any codes that specify the amount of rainfall likely to be obtained in an area, or any reliable source from which we can estimate the amount of water which can accumulate due to rainfall? Because as you have mentioned in one of your sessions that rainfall or water is the main cause of destruction of structures due to increase in pore pressure and inappropriate drainage. So what is the source from which we can collect information for amount of rainfall that is likely to occur in an area?
Yeah, Rindu, nice question. Generally, this meteorological data is available across the country. So you can go to the meteorological agencies to collect the data. So they will keep all the data available in the particular area, and we can collect the data. Especially when we go to a new area where we don't have the sufficient data, we go to the meteorological department to collect the data, and based on that we come to the conclusion. Then and the entire thing will be recorded there with the meteorological department, which is available across the country. Will be available.
Any questions from the students? We have a good number of students here. Yeah. Yeah. Well, shall we call it a day? Shall we wind up?
Yes.
All right. Yeah. Well, thank you so much. Thank you so much, Anil sir, for this wonderful session. Thank you, Garudasan sir, for being here. And thanks to all the participants for such wonderful participation. As I have mentioned, we'll be starting the next course on 10th of August. From tomorrow, we will start the registrations. You can register through our website. And please be informed through our WhatsApp group that you all are in. And also we have a Facebook page for construction philosophy wherein you can get all the updates and also visit our website for further details about the courses. And you can call us at any time on the given number. And thank you so much. Good night to all.